Welcome back to our video series for data handling for statistics. And in this video, we are doing code along file 2. Now, I do not expect to see the formatting. You don't have to make it look exactly like this, all right? I am looking for you to have everything except the lines, and this. So I'm looking for you to have everything but the comments, basically. All right, and that way I can see that you have done everything that we've done. All right, so this is code along file 2, and if you notice, of course, before I do this, I want to practice, right? So you'll notice down here in the console I have a lot of stuff, and you'll also notice that I have a bunch of stuff over here in the global environment, right? So I really don't want to have to exit out of RStudio and then come back to clear this out. So how do I do that? Well, there's two ways to clear the environment. The first is right here using the broom, and it says clear objects from the workspace. So that's one way to use your mouse and to do that. But programmatically is a better way to do it. That way, anytime you run code, you can clear out the environment if that's what you want. And so that's what I have here. This, instead of removing just one object or having to list them, this says the list is the list of all of them, basically. Okay? So if I run this code, it clears out my environment. Now, but it doesn't clear out the console. How do I clear the console? Well, that is going to be clear console is control CTRL plus L. Okay, so I'm going to do that. Watch the console. It will clear out. Control L. Now, nothing is in there. There's no scroll bar or anything here. All right, so now that we've done that, we can get started. So we've talked about some things in R, but I think that DataCamp still assumes that you understand some basic things about R that we haven't discussed. So let's discuss them. Operations. So for numeric objects, we can do addition. So what I'm going to do is I'm going to control enter. And you see that because I haven't assigned this to anything, I've just said 1 plus 2. When I run that, it shows that 1 plus 2, it also prints out my comments. And then here, it gives me the output, the result, 3. And this in brackets here is saying that there's one element, that the answer has one part to it. So it's just one number. Okay, and we'll see that when we get to a vector, it's different. All right, so here is 1 minus 5. So it's going to give us a -4, right? Well, something happened. It hit enter. Okay, so control enter. All right, there we go. So you'll see that I had a little glitch there with my computer. Something was going wrong, and it didn't read what I was doing quite right. So that's a problem with my computer, hopefully not with yours. All right, so we've got this -4 here. 5 times, so we've got addition, subtraction, multiplication, division, exponentiation, but this is a different type of exponentiation. This is the natural number e, which is 2.78 something. And so if I do e to the 1, that will be the natural e, so 2.17, yeah, I'm sorry, 2.718, all right, not 78, but 8718. All right. So if I do, so this is going to be e squared. Okay. And then I've got 5 raised to the 3rd power. So you've got the caret here. And then the number after it says take this number and raise it to this power. So 5 cubed is going to be 5 times 5 is 25 times 5 is 125. And there's our answer. Now, in statistics, we use the natural log, so log base e. And we're lazy, so we just write log. as statisticians. So if you're reading a statistics book and you see log of 3 or log of x, that's usually the natural log, okay? So log of 2 is the natural log of 2, and we get 0.693 something. If I want log base 10, which is what's common everywhere else, I have to say log 10. Now, I want to point something out to you. I've already typed this out, but I hope that you are seeing this as you start typing. EXP, and there comes EXP. You hit enter, and there it is. I can just type in, and I'm done. All right, so RStudio will, and the same thing with log. If I start LOG, once I get there, I have these, I can just select them. And once I select one and I hit enter, it puts the parentheses, and now I could do 2 if I want, right? So you shouldn't have to type everything. You should be able to type part of it and then select and hit enter, okay? So I use my arrow keys. So let's see, I've done that one. I haven't done log base 2 or log base 10 of 2. And you'll notice that this is a much different number than log base E, okay? And so let's do log base 2. That's another common, and so you see I'm using my arrow keys. You could use your mouse, and I'm hitting enter, pressing enter, and then I could do 2, and then I would have it. Okay. So that gives me log base 2 of 2 is 1. Remember that log base 2, whatever the base is, we're saying 2 raised to what number? That's x. This is, if I write x, then I'm saying what this is this saying base, so base raised to x is equal to whatever's in parentheses. In this case, it's 2. And so I'm saying 2 raised to the x is equal to 2. Well, then that means that x is 1. And that's what we had here. 2 raised to the 1 power is 2. Anything raised to the 1 power is itself. So if I change this log base 10 of 10, then 10 raised to what number gives me 10? 1. All right, so I'm going to change that back to 2. I'm going to get rid of this, and I'm going to put that back. Okay, so log 2 of 2 is just equal to 1, because 2 raised to what power gives me a 2? That's 1. Now, this funny looking thing is log of 1p. What this is anytime we want to divide by the log, we have to be careful, because log of 1 is 0. Okay? It doesn't matter what base you use. If you say log raised to what gives me a 1, that's a 0 power. It doesn't matter what the number is. So if it's base e, then e raised to the 0 power is 1. If it's log base 10, well, 10 raised to the 0 power is 1. Okay? Any number raised to the 0 power is 1, except 0. That is undefined. 0 raised to the 0 power is undefined. Okay? But so to keep from dividing by 0, we have this nice function, and what it does is it adds 1 to this. So log, what this is saying is log of 1 plus x, where x is this value here, which is 1. So this is log of 1 plus 1, which is log of 2. So this is going to give me the same answer as up here. Let's see. Yep, 0.693. See, that's exactly what I had for log of 2. And so this log 1p of 1 is the same as log of 2. So again, a lot of times we'll be plugging in numbers for log, and some of them will be 1, and we don't want to divide by 0. So if we're dividing by a log expression, we'll use this log expression. so that when 1 gets plugged in there, or 0, we can't have log of 0, so if 0 gets plugged in for x, then we'll have log of 1, and that would be, as you can see here, that's going to be 0. So log of this is going to be 0. Okay, you can't take the log of 0. So if you apply 0 to the log, but you're adding 1, then you have a defined function. I hope that makes sense. So a lot of times we'll pass a vector of values to the log, and if we're dividing by that, we don't want to divide by 0. Okay, so that's the purpose of this thing. It's nice to know that that's out there. Okay, let's talk about data types. So the first data type is a logical data type, true or false. So A2 is true, A3 is false. Now, if I look at the class for A2, it says logical. Okay? So it's saying that it's logical down here. And then the class of A3 is also logical, which makes sense. Now here is something to note. You can use logical values like numeric values. And when you do that, the true is equal to 0 and a false is equal to, a true is equal to 1. And false is equal to 0. So if I sum A2 and A3, I'm going to get a 1. Now if I sum, which one's true? A2. A2 and A2, I'm going to get 2 because they're both true, so they're 1. All right. Okay. So that's the logical data type. And then we have the numerical. So what happens here is if I set up a condition, I can say, what do I have? I have, okay, so let's say I have, I gotta be careful. Let's see, I'm using A's. Let's say I have B, and I set B equal to 5. And again, B is not over here just because I've typed it. I have to run, Control Enter. Now B shows up in the environment. And then if I say A2 equals, that's saying I'm comparing B, then it returns a false. So this is a comparison. And if I can also do another comparison, so I can say A2 is less than B. And that returns as true because A2 is true, and that is a 1. That value is a 1. Okay? And so it's less than B. And if I said that A2 was greater than B, then it's going to say that that's false. Okay? Because A2 is a 1 and B is 5. So 1 is not greater than 5. All right, so I'm adding some things. So this is what you'll want to turn in. So I'm saving this so I know what yours should look like. All right. So that's the logical, okay? And that's how we use it. A lot of times we'll use it in some statements, some comparison statements, and we'll learn a little bit about those later, not in this video. Now there's the numeric data type. And so if I type in any number, whether it's an integer or not, A1, here I've set it equal to an integer, but I haven't specified something. I've just set it to the number. Then class of A1 is saying that it's numeric. Okay? You say, but it's an integer. Why doesn't it say it's an integer? Well, here, A4, I'm setting that equal to 10L. And you'll see that the L is blue. That says there's something special about that L. So when I do this, A4 prints out as 10. A1 prints out as 10, but A1 is numeric and A4 is an integer. So they are different types. They are different classes of objects or types of objects or types of data. Okay? Now, there's something that's very useful in physics and in applications and statistics as well at the higher levels, and that's complex numbers. And so complex numbers. And so you write them just like you would see. So you notice that everything here is nice and blue, indicating that everything's a special value. So little I is an imaginary number. It's the square root of -1, which doesn't exist. That's why it's imaginary. Okay? So the square root of -1. And so you never want to set the value of little I to anything by itself. You'll notice I'm not setting little a equal to something. I'm saying A1, A2. I could say A, but I try to avoid that because that may be a special defined object in R, and if I override it, then it's no longer going to do what it's supposed to do, okay, for me. So A5 I've set to 4 plus 7I. So that's 4, a real number, 4, plus 7 times the square root of -1. And there's no way to write that as an actual value in real numbers. So if I do this and I print out A comes out as 4 plus 7I. That's the only way you can write it. I can add, subtract, multiply, divide, add complex numbers, just like I can real numbers, but they're different. Okay, and so if I class A5, it says complex. Now characters. I want to go over a few different examples because I just want to be specific about this because programmers say something and they assume that you have picked up on the nuance, and that's not always true, at least for me. So it's obvious if I set up, 2 quotes, A, that's text, right? I mean, we know that as text. So if I do A6, that's text, and I say class of A6, it says character, fine. I can also do the single. Now, let's see. If I hit this button, notice it does both of them in RStudio, and then B, right? So RStudio does make this a lot easier. Now, I look at the class of A7, it's a character as well. So whether it's double quotes or single quotes around it, it makes it text or a character. Now, well, you say, well, this has got to be a logical value. True is a logical value, but it's not just true. It's got the quotes around it. So it's in green. You'll notice it's turned green. Up here, true was blue because it didn't have any quotes around it. So if I put quotations around something, it's no longer whatever it was. It's now text. I'm forcing A8 is a character. I've forced it to be a character. And look, the same thing happens with a number. If I put quotations around it, it's a character. It's even though it's a number, it's stored as a character. Okay, so we have to be careful with these things. All right, so we've talked about the different types of data, and we've also talked about the different operations, some of the basic operations that we have available to us. There are many more, but these are some of the common ones, just basic stuff that we know from regular math, and R does this the same way, basically, except we have some functions we need to know, like log, and we need to know that that's base E. And if we want base 10, we use log 10. If we want base 2, another common base, we use log 2. If we're doing a division by log, then we may want to use this where we add 1 to the values that we're passing to it, just to make sure that we're never dividing by log of 0 because, or calculating log of 0 because that doesn't exist. Okay? Undefined. That's it for this video. I hope this has been helpful. Again, you'll want to save this code along file too. I don't care what you call it, as long as you upload it on Moodle to the right, to the code along 2 file, so that I can give you credit for it. Okay? Have fun, take care of yourself, and we will see you next time.